Namaskar. I think you have heard many water problems. As a scientist, it is our job to solve some of these problems, not all of these problems. So I'll be providing technological solutions to some of our water problems pertaining to industrial wastewater treatment. And today I'm going to talk about water treatment, not wastewater treatment. So this water treatment technology, 1 minute. This title of my presentation is Safe Water and Sustainable Technology Initiative from Indian Knowledge Base, which we can short form as SWASTIC. So this is about drinking water treatment solution that we are trying to devise, which can be an alternative to existing chlorination methods. You know, the existing methods have a lot of problems, including RO, which is also getting banned in many places now. Next one. So before going to my lecture, I'll just give you 2 slides on what work, technological solution development work we carry out. This is the first CSIR-National's hydrodynamic cavitation technology for as a vortex diode and industrial wastewater treatment. You can see the pilot plant available with us at NCL Pune and its implementation in industry. That square form, that silver color square, is our own device which is made in India and a technological solution to wastewater treatment. It has applications in distillery wastewater treatment, mainly for increasing the gas yield, because wastewater treatment, many people don't go for wastewater treatment for the reason that there is reduction in the profit margins. So here, if you apply it before the methanator, this particular technology, you get 20 to 25% increase in the gas yield, which is the advantage for the industry. For dye wastewater treatment, many dyes are refractory pollutants, and therefore this technology can be very crucial because there are not easy solutions available for dye wastewater treatment. Again, pharmaceutical industry, this is a part of emerging pollutants. Many API pollutants are there, and these can be degraded. This is not generating, this particular technology, one very big advantage is that it is not generating any secondary waste. So it is a complete disintegration of the pollutant species to water and carbon dioxide, and therefore you have no secondary waste generation. So pharmaceutical industry also, this can be applied, and basically for reduction in COD and ammonical nitrogen. Already we have commercialized this technology. There is a startup which is manufacturing vortex diodes. It's commercialized in 2015 and running in at least 30 installations in industry. Of course, we are trying to increase the penetration in the market. Next one. So of course, when we develop new technology, we have to have patents so that the knowledge is staying with us. So we have several patents, already 2 US patents and world patents are granted on this. We already have some books for the benefit of students working in this area. Technology licensed to VIII Technologies. So as a government organization, we are not selling the product as such. So there is a startup company. We have licensed the process to the startup company and they are selling the product in the market. Next one. Now, this is another form of developing technology for disinfection of water, which I will be discussing today. It is basically using Indian traditional knowledge of Ayurveda, and it's a novel hydrodynamic cavitation process which can provide complete and cost-effective disinfection of water. Like Chairman mentioned, that cost is a major consideration in water and wastewater treatment, and I will be showing one comparison of cost for other processes also pertaining to the water treatment processes. And apart from that, in this COVID-19 scenario, everyone is very aware about the health benefits. I'm sure many of you must have had some kada or something which is extract of natural plants, and in this particular technology we are trying to make use of this traditional knowledge, and possibly we can make use of the properties of these natural oils to get the health benefits. Of course, I am not medical expert, so some medical fraternity they have to substantiate these facts, but it has a potential to give some health benefits of natural oils when you are drinking water. Next one. So basically, the water key usage are for Indian scenario 10% drinking and domestic use. For agricultural purpose, we have 80%. Industry it is 10%. We will not go into the details of all this. You have already heard how the water consumption is increasing, etc. But then disinfection of water is essential for removing pathogenic microorganisms that are responsible for causing a number of waterborne diseases. 88% of the diseases in the developing world due to unsafe drinking water. Next. Now, what are the key issues in this? We have to first identify what are the key issues before we start developing a new technology. Availability of fresh water, I'm sure you don't require introduction on this, so we'll not go into it. Increased need of safe drinking water, which is very, very essential for India particularly. It is essential to adopt effective water treatment processes for complying with regulations for meeting daily water requirements and to prevent waterborne diseases. This is particularly applicable to our Indian industry, which they need to treat their wastewater before they release it in surface waters. And then finally the question is, can healthy water be provided to boost immunity? Many places now people are not interested in using RO water because they say that it's not really providing the minerals required for the body. So there are some technologies which have many disadvantages in terms of the water treatment, and therefore the health benefit or the health issues are major concern in the current COVID-19 scenario. Next one. So important issues in water disinfection are characteristics of the water to be treated, like source. There can be well water, there can be river water, or there can be some other source, and nature of pollutants. Characteristics of harmful pathogens. Microorganisms are of different types. So obviously you need to know which type of microorganisms you want to kill. Harmful microorganisms are only necessarily to be killed. Desired quality of water, obviously most stringent for drinking water. So these qualities cannot be compromised. Treatment technology, chemicals, additives, efficiency, etc. All these parameters come into picture. Harmful effects of technology like disinfection byproducts, which is a major concern for existing chlorination methodology. Place and ease of implementation of technology, particularly important from Indian point of view, whether rural or urban, household, etc. So that you can have some product at house for disinfecting water, something of that type. Cost of disinfection, this is the very important aspect of it. Single or in hybrid form, scalability, whether you can scale it up, whether I can make it suitable for household use or whether I can make it suitable for drinking water treatment for corporation water treatment plants. And operation, maintenance, all these issues are important. Next. And these are the conventional disinfection methods. Before I discuss about the technology that is developed by us, I need to give overview of these methods. We have a chemical method, which is basically a chlorination method, hypochlorite, etc. are used. There are other methods of treatment which are physical, like filtration, heating, UV radiation, thermal, solar, etc. Then there are physicochemical methods like adsorption, cavitation, etc. And then there are hybrid methods, like you combine physical chemical or chemical plus chemical and things like that. So you have hybrid methods. Obviously there will be added cost to it, and of course advantages and disadvantages of associated hybrid technologies. Next one. Chlorination is most prominently used. Nearly 95% of water is currently getting disinfected using chlorination. Next one. Now, what are the disadvantages of conventional methods? If you don't have any disadvantage with conventional methods, there is no objective in developing new methodology. So there are plenty of disadvantages. I'll just highlight the important ones. The chemical methods, major drawback is in the formation of disinfection byproducts, many of which are carcinogenic in nature. So I don't know, but some medical fraternity can substantiate this fact that there are increased number of cancer cases, especially in India and many places in the world. And in Europe parts, chlorination is now getting banned. So these are certain things that we need to think of alternatives, and which will not have anything related to chlorination or such chemical methods which will have disinfection byproducts which are carcinogenic in nature. Required dose in the appropriate level, etc. And chlorination is not effective for all harmful microorganisms. So basically it cannot really destroy all harmful microorganisms. There are other methods like ozone, etc. which also have disadvantages in different forms. Common drawbacks of physical methods include high cost and long treatment times like RO, etc. is very expensive method. Next one. So what are the possible alternatives? Now let us look at the scenario which can offer us alternative. One easy to implement alternative is the lower the formation of toxic byproducts and reduce the use of harmful chemicals. So like you can have reduced use of chlorine and less number of disinfection byproducts and combine it with other methodologies like advanced oxidation process, that is another method, or you develop altogether new methodologies for water disinfection. That is what we are trying. The important thing can be going back to nature for finding effective solutions. That is, possibly we were very much advanced in our earlier times, like 1,000 years back people say that we had something like 35 to 45% GDP contribution, then it got reduced to 25%, and after the British regime it is now hardly 2% or so. So earlier times we were quite developed, so why not go back to the nature? Earlier all our principles, Ayurveda, all those things are based on the nature. So going back to nature can possibly provide alternative solutions. Next one. So the problem statement now for developing the technology, our problem statement is find a methodology that can provide safe and healthy drinking water at low or acceptable cost with substantial ease of operation and with ease of scale up. Scale up is very important in this particular case because if you want to apply this particular technology for drinking water treatment, the scales can be huge. And of course without producing harmful disinfection byproducts. Next one. Now this is the technological part. It has a lot of engineering involved in it, and saying that not many engineers are involved, not part of this particular session. I will not go into the details of the engineering aspects of it, but this is the product, what you see the shape here. It is already patented, the patent is granted. So we call it as vortex diode. In a simple form, it generates vortex. So we have a tangential inlet, the liquid is circulated, there is a rotational flow and vortex is formed, and because of vortex there is a cavity formation, and we allow these cavities to grow and collapse. Now this is an inward collapse, so it is not explosion, this is opposite of explosion, we call it implosion, and again this is very extreme condition generating type. So you get very high temperatures of the order of 10,000 degree Kelvin and high pressures of the order of 1000 atmosphere, and because of this there is a physical breakdown. So water molecule splits, hydroxyl radicals get generated. Hydroxyl radicals are highly oxidizing in nature, which can oxidize the organic pollutants and also participate in destruction of the microorganisms. So this is CSIR-National technology, we call it cavitation vortex diode. Next one. So this is the computational fluid dynamics picture. We have to of course theoretically predict what is happening inside, because we cannot really measure what is happening because some of these, the radicals etc. are in low concentrations and not measurable. So we have to have computational fluid dynamics, we get prediction to what extent, and then we have to support the theoretical predictions using the experimental data. So this is the pilot plant which is shown here. Next one. There are other forms of generating cavitation. One is acoustic cavitation, but which is not very useful, particularly for the scale issues, and hydrodynamic cavitation. In hydrodynamic cavitation, we get number of devices. I will not go into the details of different devices because these are engineering kind of things. But then the conventional devices are not very satisfactory in nature. So this is why we have developed our own device called vortex diode. But then if you see the literature reports orifice 49%, venturi 10%, high pressure homogenizers 10%, rotor stator type devices 13%, blenders 8%, other rotor 3%, and vortex diode is 2%. Now recently I have checked it, now it has gone to 5% because of our research in this area. Next one. So this is again how water is getting disinfected because of this particular technology. As I told you, the cavitation generates high temperature pressure conditions of the order of 10,000 degree Kelvin and 1000 atmosphere. Now this is highly local condition. It's not a bulk condition, so don't worry that water is getting heated to such extent. This is not a problem. It's only at the point of implosion you get these extreme conditions of temperature and pressure, and because of this the destruction of microorganisms takes place. So disinfection of water is achieved. Next. So this is the mechanism that we get because of cavitation. Now cavitation was known for water disinfection for more than 20 years, but then still the technology was not used. Why? Next one. The reason was that you have disinfection efficiency close to only 40%, 50%, which is not very useful, because for drinking water you require no harmful microorganisms present in the drinking water. So you require 100% efficiency in the destruction of these microorganisms. So that was the main reason why these things were not. Second reason was that you required long process times. So nearly 1 hour or more than that, which obviously increases the cost of operation. Now we have a technology which we call it hybrid technology, where we add these natural oils. Natural oils are such that they have antimicrobial properties. So you can see the flow sheet, addition of natural oils having antimicrobial property, you have contaminated water, you have two-phase mixing, and the cavitation process. In the cavitation process, you have increased destruction of microorganisms because of the antimicrobial properties of the oils. So basically natural oils having antimicrobial properties are increasing the performance of the disinfection process. Next one. So these are some of the results on disinfection that we have verified that the organisms get killed, they get completely destroyed, cell is disrupted, and there is no chance of harmful microorganisms staying in the drinking water. Next one. So this is the mechanism. I will not go into the details. Those who are having microbiology background, they can understand it basically easily. There are many components in this Ayurveda mentioned which can impact the properties, antimicrobial properties, and therefore we are making use of the modern technology of cavitation and combining it with our age-old technology, that is age-old knowledge, that is from Ayurveda. Okay, so we get complete disinfection in just 5 to 10 minutes. Next one. So these are the plots of the actual results, and the present study for the first time demonstrates application of natural oils of antibacterial property in cavitation to enhance the disinfection of water. Next one. Now here you can see some of the results, how different type of microorganisms get infected. The common studies on disinfection are on E. coli, gram-negative bacteria. We have also studied the gram-positive bacteria. Both type of bacteria get killed in this process. Also, we have worked on AMR bacteria, antimicrobial resistant bacteria, which is the emerging problem again because of heavy use of antibiotics, and many of these antibiotics getting released in water. People are not paying. Of course, there are no yet standards. Someone mentioned, some speaker mentioned that there are no standards for this. So this is also one important problem which we will be facing in future. So AMR bacteria also get killed because of this process. We can also use plant extracts like ginger plant extract, turmeric plant extract, or mango ginger plant extract in this particular process. Next one. Now, if we have to implement this process, this technology for different type of applications, I can see two type of applications. One is obvious, that drinking water treatment. Existing drinking water treatments have chlorination, and if we want to replace, you can see the right side figure that I am trying to replace the existing chlorination process using the hydrodynamic cavitation process, and you can see that I have a process where I can add these natural oils, I can have cavitation process, and then the output is disinfectant water. The oils can be recycled. Oils can be easily, oil water separation is very easy, oils can be recycled back, so there is no much cost associated with the use of the oils. Okay. If I want to use this particular technology at household purpose, okay, then I can have a similar like AquaGuard kind of activity, one box where I can have a high pressure pump and this natural oil is getting injected. The advantage that we can obtain using this technology is that depending on the nature of the benefit that natural oil can offer, we can mix those oils and get those health benefits possibly. That is another, so of course that is for future studies. So this is one very interesting observation which is from this new technology. Next one. Now coming to the cost. Cost is important parameter. Why we are not using RO or such technologies for drinking water treatment? Obviously cost is unmanageable. Nobody can really afford it. So we have compared the cost of our process. We need to have a technology which will have comparable cost with chlorination. And you can see this particular plot where hybrid process cost is much lower. It's comparable to chlorination. Okay. So this is the biggest advantage. With vortex diode cavitation alone, the cost is $0.22 per meter cube. So it will come something like 5 paisa per liter or something like that. It's very, very cheap technology. Next one. Now hybrid technologies is very important because no one technology can offer you complete solution. In water or whether wastewater treatment, no one technology gives you complete solution. So hybrid technology is the future. So with this, we can also combine other technologies like adsorption, ion exchange, oxidation, or biological treatment on membrane separation like arrow, etc. Next one. So, yeah, just 1 minute. So this is the bio-nanocomposites application is another use of natural resources for making bio-nanocomposites. Here we can have traditional method like carbon, like copper or silver in these bio-nanocomposites, which can also disinfect water. The nanoparticles, like silver nanoparticles used, etc. in disinfection is known, but again cost is a major problem, and application, how to use it for different type of treatment methods is a major problem. So here we can combine this with our technology, we can get possibly more economical solution. That's why I am showing you this. These are the alternatives. We can also make use of ghee, Indian traditional ghee, which has also very good property from health point of view, and generate these new adsorbent materials. Okay, next one. Next one. So comments on CSR NCL's technology on this swastik. It has exceptionally high rates of destruction of common as well as antimicrobial resistant bacteria. Disinfection within 10 minutes, quite manageable under mild operating conditions. The hybrid process is also effective with conventional devices like orifice. Simple process intensification such as aeration can also reduce the use of natural oils. It can provide alternative to existing chlorination. No disinfection byproducts are found. So our technology for the first time provides useful method for destroying bacteria, including antimicrobial resistant bacteria using cavitation and natural oils or plant extract, and also for enhancing the removal rates, reducing the cost. So it is a green technology, especially for household, corporation or rural use. Next one. So this is the summary about CSR NCL's technology. The first two are pertaining to industrial wastewater treatment, which is not the topic of my today's presentation. So you can leave it. Our technology is swastik, that is Safe Water and Sustainable Technology Initiative from Indian Knowledge Base, can have significant benefits in terms of providing this safe water. Next one. Of course, technology development is a teamwork. So we have a very good team with postdocs, Dr. Gayatri Sorokaiban, Dr. Yosna Jena, Dr. Kshama Palapure, Dr. Pooja Dhanekar, and many of my students, Soumya, Nalini, Pooja, Praveen, Chetna, Maya, and many of these students have contributed. Next one. We are also having a project and water center which is inaugurated in 2019 at IIT Bombay. So we are working with the DST on this water center for providing solutions to industrial wastewater treatment problems. We are also working with many industries. You can see some of the photographs with Vapi industry bed, JNPT port, and etc. Next one. Apart from this, what I discussed, there is another topic on which we are working, that is desulfurization of fuel, which we received technology award from Honorable Minister of Science and Technology and Vice President in 2019. That is desulfurization of fuels. Of course, those who are interested, they can read it on net. Thank you very much for your kind attention.